Good. How are you?
Fantastic. Now, I've known Jennifer for
Oh,
what? Like
a
15 years?
long time, my friend, a long time. So back in the day, back before machine learning was cool and like everybody was doing it, it was like me, Seth, and Gary Short. We're like doing
That's
all
right.
of the machine
3
learning
of
talk.
us.
It was like the three of us on the speaking circuit all the time, and we would always run into each other. So yeah, Seth and I think I met you at one of the Tennessee conferences. I forget which one.
Code stock.
Code Stock, that was it. Okay.
I
Yep,
think it was
you did a
2008.
workshop. Yeah, it was a long time ago. It was a long time ago.
And when we
I
say the
know.
only 3, we mean in the .NET space because we were obviously, there's people doing machine learning before, but in the .NET space,
Mhm.
it wasn't something that people were thinking about yet, and to be honest, it really
Yeah.
hadn't reached the zeitgeist. So what are you talking about today? And maybe I'll turn it over to you.
Oh my gosh. Well, what I want to tell you about today is it's like, all right. So, one of the fun things that I get to do at work at Microsoft is I get to create demos for the CTO. I am Microsoft CTO Kevin Scott's demo engineer. So, that's one of the things that I get to do that's super fun. But when you do like cool demos, like a lot of times it's just like the final product, yay, look, it works. But you don't get to see like all of the thinking that went into it. So what I want to do today is actually share with you guys the whole mindset I went through when I was trying to do a demo to solve Wordle. Um Okay, so this is gonna take you through like the very beginning of like what was my very first prompt, what did I try, and then we're gonna walk all the way through and see if it can be done. All
All right.
right, so that's
I'll
the
leave you
plan
to
for
it.
today.
I'll leave
All
you to
right,
it, my friend.
cool, cool. All right, so let me start by like, what is Wordle, just in case folks don't know. So Wordle was actually this source of joy during COVID. Do you play Wordle, Seth? I don't know if he does, but for those of you who don't play Wordle, what it is you guess a new five-letter word every single there's a new puzzle every single day, and it's a five-letter word. So you just guess random letters, and then each time you make a guess, it has to be a real word. So if I knew that there was like a K, an L, and a W in it, then I would have to guess a real word that contained those three letters. You can't just put like a random string of letters in there. It has to form an actual word. And there's a new one every day. It has to be a thing. And you have 6 tries to get it right. Okay. And then the last thing to keep in mind is that the color is really, really important in solving this. So after you submit a word and hit enter, the letters will all turn colors. And if it turns green, that means that that letter is in the word and it's in the right position in the word. And then yellow means that letter is in the word, but it's in the wrong spot. And then this light gray means that it is not in the word at all. Okay. So that's the very simple version of it.
Yeah, I never
So
got into it.
you didn't? Oh, I
I was
love
so
Wordle.
bummed.
It
Like,
was,
everyone, like, they would post it on social media. I'm like, "What is
yes.
this?"
Yeah. No, it is so much. It was like my source of joy during COVID, like when everything else was kind of falling apart. You
Yeah.
had your cup of coffee in the morning and your 5 minutes to do the Wordle, and you were like, this is fine. The whole like fire in the background meme was like just totally Wordle was my this is fine.
Would I
So
be able
I
to
love
start it?
this. I love
Would I
this.
be
I
able to
love
start it now and be cool, or is it, like,
Yes. I
fast?
mean, be cool. I don't know because I guess it's probably it was like really cool during COVID, not because you're not cool, because you
Oh, god,
obviously
okay,
are.
yeah, oh, I got you.
Obviously, you're cool, but,
Sure.
like, just it's probably peaked at this point, but I don't
Yeah.
know. I still love it. I still play every single day
Okay,
because I am a dork.
okay.
But let's talk about why I thought this was such a cool problem for machine learning. Why I thought this was cool is it actually, when you think about the what you need from that image. So if we start to think about image understanding, right? What you need to pull out and extract from that image is three distinct things. You need kind of the OCR type knowledge to understand like what characters are on the screen. You need positional information that's super important because you have to know like was it in the third spot or the second spot so that you know like where it belongs. And then you also need to know the actual colors that it turns because the color gives you that information about whether it's in the word or not and whether it's in the right spot or not. So all of that is super important. And that's and position especially, like as you guys probably know, that is really, really hard for these large language models, like all of them across the board. Industry wide, this has been a hard problem for large language models is positional information of how things are relative to each other within an image. All right. And it's fun. Like
Yes.
doing something with Wordle would allow me to do something fun and interesting. It gave me a reason. Like I have to do this Wordle every day. It's for work, you guys.
Yeah.
And it helps you guys learn, right? Because it's fun and interesting. And so always choose a fun problem when you can, because it sticks in people's minds. All
I
right.
love
So let's talk about like the limitations though. So this is taken right from OpenAI's webpage. And so one of the things I'm going to call your attention to the bold here. One of the things that is super important is that like spatial reasoning, again, as I said, is a known hard problem with these models. And when I created this, I actually created this November 2023 is when I was doing this work. So I submitted it to a conference in December 2023. So this is something that is I was using GPT-V, the Vision preview at the time, which had just been announced by OpenAI on at their Dev Day that year, which was on November 6th. So anyway, this is a known thing that this precise spatial location within it is hard. So just keep that in mind as we're thinking through this. All right, so let's try. Here's my very first thing that I tried, you guys. I started with the hello world, and any hello world with a vision model, with an image understanding model like GPT-V or GPT-4o can do this as well. The Florence model can do this. There's several other image understanding models. Um, this is the hello world of image understanding is describe this image or what is this? So I did do an image like that. I think I said describe this image. And I put in an image like that. And what that allowed me to do is just understand, does the model have some understanding of Wordle in its training data? If I just give it a screenshot of a Wordle image, and I actually cropped it, I actually had a landscape image, but I cropped it so it would fit on the slide. If it has this information, like does it know the rules of the game? Like what does it know? And this is what came out. So what this told me is that yes, the model did have knowledge of the game of Wordle because it said this is a screenshot of a Wordle game. I identified the game. It knew the rules of the game here. So it gave me kind of a quick description here. And then it actually kind of walked through and I highlighted the things in here that are wrong. So you can see it was not able to just in one perfect prompt, well, one very simple prompt to describe this image, it wasn't able to get it all right. So none of these letters are in the correct spot was incorrect for rates because you can see it actually there was a green E, which gives us a lot of information. It said L is in the word, but not in the right spot, but that's wrong. It was actually the I that's that way. And then so it kind of it got it superimposed, it transposed the L and the I here. It thinks O is green. It probably was getting the green from below because you see O
it.
is right above a green here. And then N it got wrong. So you can see this is not perfect. We got our work cut out for us, guys. All right. So what did I do? I started by looking at this one really cool research paper that was created by Microsoft Research. They did a look at kind of a deep dive exploration. I had actually done one as well. And I wanted to see the one that MSR had done on GPT V and like what its capabilities were. And so one of the things I wanted to see is like how well will various things work. And one example actually uh, was really interesting to me. I'm going to jump out and just pull up the paper real quick so you can see it. Okay, so this is the paper. Let me zoom in a little bit if you guys can read it
Nice.
a little better. There we go. Okay, so this seemed similar in hardness to what I was trying to do. This is an example that they gave. What is the read of the speedometer essentially? And you can see it is totally getting it wrong when you ask zero shot, which means apropos of nothing. We're not giving any examples. We just ask and we want a response, and it cannot do that. The other thing you can do is something called chain of thought reasoning, which you probably talked about on the show before, Seth. But that's the idea of thinking step by step, because when you move through and kind of are telling what your assumptions are, it can use that information to make better judgments. Um, and so right here, let's think step by step. So, okay, it's kind of giving you a little bit more information here. It's still getting it wrong though in this thing. And then here, we're actually doing two different things together. Or I'm sorry, we're doing a different thing. We're going to try, let's give it text instructions. So instead of just saying, what's the read on the speedometer, we're telling it how to read the speedometer. So to read it, observe the needle on the outer edge, which points to your current speed, represented in miles per hour. It actually has kilometers per hour in the inner thing as well. But it's asking for the miles per hour. And it says yellow is the color of the needle. So we're giving it that information. and it still is like, nope, not getting it right. Okay. So then combining those two methods, the think step by step for some of that chain of thought reasoning capabilities, and with text instructions, putting those together, you can see it gets a little closer. It is thinking step by step here, and it gets it all the way to the end. It still does not get it. All right. And then what we're actually able to do here to solve it is using a technique called few shot. So what that means is giving examples in this domain. So now when we're saying what is the read of the speedometer here, it gives the right answer back and then gives another one and then asks for the answer to that one. And note that we're still not able to do it here. And then again, another example that's still not able to get it. And then we tried again with multiple two shots. So we're using two examples now. And what I like about how these two examples were chosen is note that the needle points one way in one and then the other way in the other. So that can help tell it that it like, it's not that it's actually, just in case it was kind of always using one area, it kind of recognized that it's the pointy end, not the rounded end, that matters. So that will give you more information. So choosing your examples smartly is good. And then see, yay, it actually finally gets it at this point. All right. So we can do this. This is doable. So that gave me hope. So let's jump back to my thing right here. So I use this example, and then the big insight right here is use few shot examples, right? And so this is something I've talked about in a lot of my talks in the past. Like few shot reasoning is very helpful. So I did that. I put in a couple of different examples. I've been screenshotting my Wordle boards every single day, and those are all in the GitHub repo that I will share with you at the end of this talk, where I
Nice.
have all this posted. Yeah. So you guys can go check it out. And I actually have all of it. It's actually a horrible code if you're one of the people who likes like code deleting, because this was the spirit of a journey talk, I left in like all of my old code examples. Like I tried this, then this, then this, then this. So there's all of these different old code in there, but you can see the whole thought process as I went through. And so you can look here. I did few shot on this one. I actually used two as my end just because I think probably because I saw it in the paper too, and it just two was stuck in my head. But I gave two different examples here. And then notice on the very first try, I got a few colors wrong, a few positions wrong. The character extraction happened to be correct that time, but with generative AI, remember you can never run it once and then extract patterns from that. It's a different output every time, non-deterministic. So you must run it lots and lots of times and then kind of see over time, like does it work or not. And so color extraction actually, or character extraction, is actually not correct over time. And I can show you the code on this super quick. I'm worried about running out of time here. But here's kind of what the code looks like here. Let me also try to zoom in a little. So this is like what I was doing here. And the prompt that I'm using is focus on the letters and colored boxes in the center of the image and list all letters in green box and what column they are within their row. List what letters are in yellow boxes and their position. I think I said position. So I said column here, I said position here just to change up the wording, and
Right.
list which letters are in dark gray boxes. And we don't care like where they are in the row because we just know it's not in there. So the where it is doesn't actually matter for gray. All right, this is just how you base encode an image. We here are my few shot examples. These are in the GitHub repo, so you can go look at them later if you'd like. And then just kind of the content headers. And then at this time, so when I was creating this, like it had just been released, so we didn't have a nice clean SDK. So that's why you see this ugly code where I am literally hitting the REST endpoint and like putting this all together myself. What I need to do is go back and like clean up this code, refactor it, because now we have lovely SDKs to do a lot of this and make this code a lot neater. But at the time, we did not. And
There's
so
no shame
I
here.
use my
We're not gonna shame you, Jennifer. This is great, and you take as
it's
long as you
no,
want.
no,
This
no.
is not
I'm calling out best practices. I'm calling out best practices as I go along. But definitely this code, I feel shame on it. But anyway, here we go. So identify the letters, guess what color it is. So a very basic system prompt that you might see. I pass in the text here. I kind of have a little thing. And then here's my few shot examples where I have the assistant and then I give the right answer. So here's what I want. In this puzzle, this looks like this. In this puzzle, this, and here's another example of what it got wrong. And then here's the actual one at the end. And now we're kind of doing our little dot, dot, dot for the completions API to see if we can get the right answer. Okay. So let's jump back to this. Took a quick look at one of those early of code. And then you can see that, yes, it does not always extract the characters, as I said earlier. So this one missed the Y and didn't get the Y right. And so what I realized is that no, it really couldn't do of the three things we need to find out, you guys, the position, the actual characters or OCR, whatever you want to think about it, and the colors, I was getting none of them consistently right. So taking a step back, I started to think about characters first. And so let's just think about how the model represents language, right? So we as humans are very familiar with the concept of words and we're familiar with characters, but the model actually thinks in tokens, right? So let me just give you an example of what those look like for the three of these. Um, a word might be standoffish, and what that means, if English is not your native language or you're just not familiar with that word, it's like it means kind of aloof or stuck up a little standoffish. You don't always engage. And so if we break this into characters, obviously each letter would break into its own character. And when we tokenize this, it actually forms three distinct tokens, because ish is kind of a suffix in the English language that means like having characteristics like this adjective. And then standoff is like you're aloof, you're standing off, but there's kind of these two separate concepts of stand and off that are coming together, which is why I chose this word. So standoffish actually tokenizes into three different tokens. All right. And we can actually, if you want to see how your language tokenizes, there is a tokenizer on the OpenAI website here, and you can actually enter things in here yourself and see how they tokenize. And there's an example here. I'm going to skip it for now, just because of time. But like, I'll just try Jennifer's queen-like behavior. Sorry, I was trying to do the British you there. All right, and you see how this tokenizes? So in the English language, apostrophe S is the possessive, but that kind of has its own little concept of being being possessive of Jennifer's, like belonging to Jennifer. And then queen like, kind of like ish, like is another suffix that means has behavior like. So I could change this to CEO like or childlike or whatever. And those two would tokenize separately, and then behavior is all by itself. Okay, so does that kind of make sense that it tokenizes into these distinct concepts, and it could be sections of characters or it could be a whole word by itself. Okay, so that's what tokenizing is. So that was our quick sidebar on tokenization. So I started thinking about that and thinking, man, characters aren't extracting well because it really doesn't have a concept of characters. So I started doing some. All right, these are what I already showed you online. This is the example that's on the OpenAI website. You can go and try that yourself if you'd like. Here's the demo I did, so I'm going to skip over those. So I was thinking about like representation of characters, and I was doing search and research on this, and I came across a blog post by Andrew Main. And so Andrew actually used to do evangelism, kind of what I did for Microsoft. Andrew did for OpenAI for a while, and we actually connected and we're working together on some stuff at Build, not this year, but last year, I think it was. And Andrew had created, I found this, I did not even realize this was out there, but he had written a blog post on playing Wordle. This was before the vision model. So this was just how to do it in straight text. And there's some good stuff in here, but the big insight I picked out of this is if you put square brackets around the characters, that helps the model understand to extract the character as its own little token. And I was like, let me try that. Yes. So what I did is this is kind of the same. So this is what my system prompt looked like, and you can kind of read that at your leisure. This is what you can do, model. Here is a new image. Because I was doing few shot, I wanted to start my user prompt with here is a new image. So it didn't try to take there's a yellow L from